Hey everyone, I'm Ivo Georgiev from Ambire Wallet, and I'm gonna tell you about demystifying account abstraction, EIPs, ERCs, RIPs, you name it. As you know, it's been a really complicated topic, and this talk is kind of weirdly timed in a very good time and bad time at the same time, because Vitalik is speaking at SafeCon on account abstraction. So basically continuing Vitalik's work here. So here is a brief agenda of what we're going to talk about, and we're going to start with the big picture, and the big picture is going to be like the landscape. You're going to see it visualized. Then we're going to touch upon ERC 4337, what it is and what it is not. Then we're going to go into evolution of native account abstraction or enshrining account abstraction into Ethereum and the EVM ecosystem in general. And then we're gonna move into intermediary solutions, which are really popular at the moment. And finally, we're gonna cover signatures, which is just like a huge pain point for dApps. So first of all, who am I? Who are we? So I'm the co-founder and CEO of Ambire Wallet, and Ambire Wallet is one of the first smart contract wallets on Ethereum entirely. And it was built in 2019 as part of ADEX network and then pivoted into its own thing, spun off. And we launched one of the first consumer-centric account abstraction wallets in 21. And since then, we've grown to over 100,000 wallets. And we also won an Ethereum Foundation grant for building email-based account recovery through DKIM signatures. And finally, I wrote a very cool ERC for verifying signatures from smart contract wallets that aren't deployed yet, so counterfactual accounts. And you know, why is account abstraction valuable? Most of you probably already know this, but I would say that one of the first things is easier onboarding, thanks to being able to pay gas in tokens, being able to prepay for gas, and etc. Another really cool thing is that we can get rid of ERC20 approvals, which is thanks to transaction batching. And also we can recover accounts, so you know, social recovery, onboarding people without a seed phrase, and letting them recover their account even if they lose access to it. And finally, quantum resistance and being able to implement alternative cryptography, and for example, implementing passkeys. And you can see a demo for almost all of those features in the web version of Ambire. We haven't implemented, like, for example, passkeys yet, but we rolled out almost all of those features that are mentioned here. And another big question is when account abstraction, right? And the answer is now. So there is a big misconception in the space about what those EIPs and ERCs do, because people think that those EIPs are going to lead to those features being available on mainnet, but the reality is those features are already available on mainnet. And most of the EIPs and ERCs only make those features more accessible, easier to build, etc. So this is a big visual overview of the account abstraction landscape. And basically, things started with, there's been a million proposals, but EIP 2938 was the original native account abstraction, and then it evolved into 7560, but that was thanks to ERC 4337, which kind of picked things up and became like the renaissance for account abstraction. And a really cool thing about this is that none of those are competing. So they're only competing for attention and for memes, but almost none of these proposals are competing with each other. So let's start with 4337, and I really assume that most of you are already familiar with it. But there's been a few misconceptions about 4337 to clean up. And one of them is that it is a standard. It's not really a standard. What it does is it's one of the first account abstraction proposals that doesn't include any protocol changes. So it's really technically kind of a standard for relayers, a standard for decentralized relayers, and it implements the feature of being able to broadcast account abstraction transactions and include them without actually modifying the Ethereum protocol. So it's not a change in the Ethereum protocol, and most importantly, it doesn't add any new features. It doesn't enable any new features. It just makes building those features easier. It's not native account abstraction. That's something that you will hear many times, and it's not enshrined to the protocol, which has its own advantages and disadvantages. For example, the advantage is that it's easier to implement, and it started a renaissance in the account abstraction space. But a disadvantage of this is that it comes with additional gas costs. So yeah, the benefits, it made everyone fall in love with account abstraction again. It was really easy to implement in terms of not requiring any protocol level changes. And the best of all, wallets no longer need to develop these proprietary and fragile relayers. And unfortunately, though, it has a few weaknesses. Like, for example, a high gas overhead. The gas overhead of ERC 4337 can get up to 200,000 gas or even more. And it cannot go pretty much any lower than 50,000 gas. So another disadvantage of 4337 is that it doesn't add any functionality to existing accounts. So if you have your EOAs, you cannot make use of account abstraction on those EOAs. And you have to move funds to a different account, which has been a huge blocker for adoption in the space. And personally, I think that this is one of the reasons that account abstraction hasn't seen more adoption, because people are just kind of psychologically inclined to stay on their existing accounts rather than move funds to new accounts that they potentially don't even trust because there's a smart contract underneath. And another disadvantage of 4337 is that it has a high development overhead compared to simpler proposals. So how do we solve this? We solve this by enshrining account abstraction, as Vitalik said, and this can come in many forms. And over the years, there's been literally 1 million proposals. And one of the things that people don't really know about account abstraction is that Ethereum was actually meant to launch with account abstraction. But they literally ran out of time, and the team was really hard-pressed to launch as soon as possible. So that's why it got left on the sidelines. And yeah, we have a screenshot of the original Ethereum white paper, which literally states that accounts can be contract accounts. And we have a brief history of all of the proposals. So things started in 2016 with EIP 86. And that was basically all about abstracting signature validation and nonce checks. And that was sort of inclined from the perspective of quantum resistance and like alternative signature algorithms, but not only that. And then after that, the focus kind of shifted to being able to pay gas in stablecoins or in alternative tokens in general. And then we had the first complete proposal in 2020, which was EIP 2938. And then we had this EIP that became so controversial lately, which is 3074, and we're going to get to that in a minute. And then 4337, then there's a bunch of other ones, and as I said earlier, 7560, which took the learnings from 4337 and proposed enshrining them into the protocol. So are any of those live? And almost in all cases, the answer is no, but some replace the others, right? So it doesn't make sense for all of them to be live. But 4337 obviously has been the most successful one. And now we come to a very interesting topic from the last couple of weeks, and this is ERC 3074 and ERC 7702, although we're going to get into that. But the thing is, 3074 has been compared a lot to 4337 in the past. Like a couple of months ago, I've seen tons of these comparisons on Twitter, and this is one example there. And the thing is, they do not solve the same problem. One solves sending transactions, relaying transactions, and paying the gas for those transactions, and the other solves converting EOAs, kind of. Not exactly, but retrofitting account abstraction on existing EOAs. So it kind of started as a very big meme war between those two ERCs or EIPs or whatever you call them, but both can coexist, although later on the 4337 team found that even though they can coexist, it's not really an elegant integration between them. So yeah, ERC 3074 was like sidelined for like 3 years. Then core devs pretty much kind of randomly decided to help account abstraction and scheduled this EIP for inclusion. And then later on, the 4337 community realized that there's so many like compatibility issues. And then Vitalik came in at the last minute and pretty much saved the day with EIP 7702, which is sort of a rewrite of 3074, but in a way that's way more compatible with 4337 and generally more elegant. And yeah, EIP 7702 is EIP 3074 reimagined. It's much more compatible with 4337, as I said, and it doesn't add new opcodes, which makes it much easier to deprecate in the future. Because one argument against 3074 has been that we're enshrining these like kind of ugly hacks, and then in the future, when we get a real native account abstraction, we wouldn't be able to get rid of 3074. But 7702 solves this because it doesn't include any opcode changes in the EVM. It's just an alternative transaction type. And a transaction type is really easy to get rid of. You just need to get rid of it from the Go Ethereum implementation or whatever the node is. And basically, you can help transitioning to full account abstraction, to full native account abstraction. So one very significant difference between 3074 and 7702 is that in 7702, accounts have contract code during execution. And why this is significant? Because it breaks DApp compatibility with dApps that already discriminate against smart contract wallets. So, like for example, there's been many of those NFT mints that check if the core is a contract, and if the core is a contract, they just revert and they don't allow you to mint the NFT. And the logic behind this is kind of stupid. They've been thinking on how to get rid of bots and how to disallow bots from minting their NFTs, but this breaks the whole account abstraction compatibility, right? So like you cannot mint it from a safe, you cannot mint it from Ambuyer, but 3074 had potential to solve this, but with 7702 we wouldn't be able to because the contract still has code, the account still has code during execution. But this is actually a really small price to pay because it brings a huge advantage, which is that you can validate signatures through 1271 during execution. Why is this significant? It's significant because, like for example, I can have my EOA and add a passkey to it, and without this trait, I wouldn't be able to sign messages using the passkey and have those messages validated in the transaction execution. So yeah, for everything else, the trust assumptions between those two EIPs remains absolutely the same, so you still have to really trust the implementation, but that's true for literally any account abstraction wallet, and not only account abstraction, it's true for any wallet in general, right? When you put your private key into MetaMask, you're trusting the MetaMask implementation and the MetaMask code not to leak your private key. So it's pretty much the same with account abstraction. When you're putting your funds into an account abstraction wallet, you have reasonably verified that the contract that you're putting funds into is secure. And finally, one of the most interesting aspects of account abstraction, and that's signatures. And again, there's been a misconception in the past that actually this misconception is changing, but there's been a misconception that contracts cannot sign messages, and it's kind of true. Contracts cannot sign messages, but contracts can implement message validation logic, which allows, if it's a contract account, to define a standard in which messages are being validated. For example, if it's a safe, then the function would just define that the message needs to be signed by all of the signers on the safe, right? So this is an example of how EIP 1271 works. And you define a function called isValidSignature, and in that function, you define your own logic for what constitutes a valid message for this contract account. And yeah, that's basically how contracts can sort of sign messages. They don't sign messages, but the signers that own this account sign messages, and then the contracts define how those messages are validated. So there's one big flaw with this, and it's that you cannot verify signatures from contracts that are not deployed yet. And why is this a problem? It's a problem because we want account abstraction not to make any steps backwards from your ways. So what we want to do is we don't want the person to have one additional step to deploy their account. In the past, that was a standard for account abstraction wallets. You would sign up, and then the wallet would say, please pay this gas to deploy your account, which is an immediate step backwards from EOAs because EOAs don't make you do that. And it's super counterintuitive to ask for someone to pay a fee for something that they don't even know that they're going to use. So yeah, a bunch of account abstraction wallets worked like this in the past. And then everyone switched to counterfactual deployment, which is really cool because counterfactual deployment allows you to delay deployment until your first transaction and hide it from the user completely. Like for example, I would create an Umbire account. It won't get deployed on chain, so on Etherscan it would just look like an EOA. But then the moment I do my first transaction, the deployment would get batched together with the transaction itself. So the contract would first deploy my account, and then it would execute the transaction that I actually want executed. So the user doesn't even notice this. It's like 40,000 gas overhead, and on layer 2s especially, you cannot even know that it's there. So we're completely abstracting this step away. And Safe, of course, obviously, Safe switched to this as well. But the problem with this is that you cannot verify messages if your account is not deployed yet. So that creates a whole another drama because I can go on a DApp, and the DApp could be, let's say, on Optimism. And because I've never sent transactions on Optimism, the DApp wouldn't be able to log me in because the DApp cannot verify my signature. So that's a problem. And the way it's solved is through ERC 6492, which is an ERC that merges all of the different signature types into one single validation contract, which doesn't need to be deployed on chain. It gets invoked through it call off chain, and it can verify signatures from contracts that are not deployed yet. It can verify signatures from contracts that are deployed. It can also verify standard easy recover signatures. And this ERC extends 1271. It doesn't compete with it. And also shout out to Sequence, who also helped with this ERC. But yeah, that's the main thing that it does. It allows verifying any type of signature. And we also built a library that allows you to use this ERC really easily. So it's like one NPM module, and we really encourage every DApp to switch from ethers.verify message to this library, because you don't have to care about all of the account abstraction complexities of verifying a message. You just have to call one single asynchronous method, and you've got all signature cases covered, including EOAs. And yeah, let's go into satellite EIPs now. And the first thing that I want to mention is modular accounts. And there is literally the first case of competing ERCs here, other than 3074, is the case of the modular account ERCs, which are competing. One of them is built by ZeroDev. Then we have another really cool ERC, which is 5792, which allows the dApps to send batch transaction batches to the wallet, which is really cool because this is the thing that's going to kill ERC20 approvals, right? Because we don't need to actually kill ERC20 approvals on chain, but we can abstract them away by batching them together with the action. And the cool thing about this is that we don't need to make infinite approvals anymore, and we can make exact approvals, which after the action has been completed, the exact approval gets zeroed. So you no longer need to have open approvals. And yeah, there's a bunch of others which I can go into, but what I want to mention is that there's a bunch of EIPs now for alternative cryptographic curves, which is going to allow us to verify passkeys with significantly less gas. So that's cool. And I suggest that we move on to questions. One question there?
What is the overhead in terms of gas of ERC 7706?
You mean 7702?
O2.
Yeah, I know, numbers are, it's crazy with the EIPs and numbers. So there is no, it's not defined yet because the standard, as far as I know, is not written to a level which specifies the gas usage of this new transaction type, but it's expected to be really low. So like, for example, for 3074, there was overhead which is equivalent to delegate co, so like a few thousand gas. So I'm expecting it to be something like this as well. And another thing worth mentioning is that because it's compatible with 4337, multiple user ops from different users can be bundled together, which can further save gas and can actually make account abstraction cheaper than EOAs. In other words, it's negligible.
Okay, thank you very much, Ivo. Everyone give a big round of applause for Ivo again.
Thank you.